Great. So, look, I'm really pleased to be talking to you at the OpenUK event about kind of the interesting symbiotic role that I think open source has with the efforts to improve the sustainability of technology. Oh, sure the clicker is working. So I should say I was planning to be joined on stage here by a female colleague, Charlotte. Unfortunately, she's unwell. I then found another female colleague that could talk about this alongside me, and unfortunately, Anna's also well. So Anna and Charlotte do get well soon, but I had hoped to have another colleague on stage with me. I'm supported by a team, quite a diverse team of junior people and different genders and so on. So I was trying to get someone who also represented the other aspects of the team on stage as well. But a little bit to kick off about my journey into this sort of, I suppose, the awareness and understanding of the sustainable impacts of tech. I suppose throughout my career, it's been a sort of a toss-up between sort of scientific side of things and computing. I've always been as much of a science nerd as a tech nerd, I suppose. And it was, yeah, so my education was computer science, sort of classical computer science sort of background, developer and so on and so forth. But actually, fairly early on in my career, I did a stint at an energy and climate change consultancy, energy environmental consultancy, developing carbon calculators and emissions reporting systems and things like that. And that really spurred my interest and gave me a good grounding in energy and renewables and other things like that. Unfortunately, the financial crisis of 2008 came along, and that meant that I had to get a job in another sector. I ended up working in the energy sector for some time as a tech architect, and then in various other sectors. But what I'm excited about at the moment is I've now feel like I've come home, because joining Scott Logic about 18 months ago, one of the things I was asked to do was lead the sustainable technology practice and talk a bit more about what some of that work is, particularly the open source stuff that we're doing shortly. One of the other things I do is I lead a podcast called Architect Tomorrow, and this topic, along with the other topic that I suspect most of the rest of the conference is at, the AI theme, is clearly a draw. So I'm covering that, but I'm also covering a lot on sustainability, and I'm also keen to talk about where those two intersect as well, and I'll touch on that in my talk. So a bit of audience engagement. Where are you on your tech sustainability journey? I've just got a few questions for you. If you could show of hands, how many of you use a reusable water bottle, for example? Okay. How many of you, when you finish the night, how many of you leave your house lights on, your oven on, all your various appliances on when you go to bed? Anyone? No. Okay. Unfortunately, we're kind of doing the equivalent of that in the tech space in some cases. We're not, being conscientious about when we're using technology and how we're using it. We're just consuming it, right? And so there's two sides of this digital kind of coin, this tech coin, that I don't think many people really, I think some people in this room, many people in this room, sorry, will understand it because you're more technology savvy and you understand the fact that when you use your phone, you're using APIs that are then talking to back-end servers in big data centers, right? We understand these things because we're more familiar with the industry. Most people out there just tap on their devices and use their laptops and have no real clue, A, how that device was created in the first place, what will happen to it after it's disposed of, and they have very little understanding of the impact of the massive data centers that are powering their everyday digital experiences. Now, don't get me wrong, I'm not a Luddite. I love technology. I really enjoy technology. But I think we can just constantly keep on growing and adding more and more services and storing more and more data and not thinking about what impacts does that have. Maybe we don't see them day in, day out in our part of the world, but in other parts of the world, there is real world impacts of our tech consumption. I'll come to that a bit more in a minute. The UN Sustainable Development Goals. So how many people are aware of these? I always like to ask. Great, good, nice. So one of the first pieces of work we did with the UN SDGs was look and think hard about where does technology really impact these. And I don't have time today to cover all of the impact sort of analysis we've done, but I am going to focus on a few. So I'm going to focus on some of the more obvious ones when it comes to environment and some of the less obvious ones, because I think this is an important piece. I've done separate talks on this topic before, and they're available on YouTube. So there's one by the Intersection conference last year, which I recommend you go and check out if you want to explore this in more depth, because I'm going to need to cover this quite quickly and move on to the sort of open source ecosystem point that I want to make. The big thing that a lot of people think about is the energy consumption of our devices. That left-hand side, the affordable and clean energy, SDG 7, they think about how much energy the servers or the laptop or someone consumes. And in a lot of cases, forgetting this right-hand side, this responsible consumption and production side of things, the fact that when we buy devices or when we buy and procure cloud services or hosting services, There are material impacts in the manufacturing of the hardware, of shipping that hardware, maintaining that hardware and disposing of that hardware. Those impacts are what's known as embodied carbon. So the energy consumption is the kind of operational carbon, the electricity-related carbon dioxide, but the embodied carbon often gets overlooked. And for certain types of devices, like phones, it can be 80% of the impact of using a phone can be in its manufacture and its impacts before you've even started using the thing. And it makes sense, right? When you think about a phone, it doesn't consume an awful lot of electricity to recharge it. Servers, it's typically the other way around. It's typically 80% of their emissions are related in operating them and 20% are in their manufacture. But we need to think about this in the round. And I think a lot of this is just hidden below the waterline. We just don't see it and we don't feel it. I won't go into all of this, but there are knock-on impacts to life on water, life on land. Clearly, there's a climate action one linked to the clean and affordable energy piece as well. But we just need to start thinking a bit more holistically about where things connect. And thinking about holistically, viewing sustainability, I like to look at this as a broader concept of sustainability. Green and carbon aware are one component of sustainable technology. We've heard a lot of talks like yesterday about the sustainability of open source, like how do you find people and how do you kind of maintain an open source project? And the same is true of any technology. You're getting access to skills, managing the security and the risks and so on and so forth. All of those things I still put in the bucket of sustainability. There's an economic viability piece to this as well. Technology costs us significant money to run and operate. And how can we reduce that total cost of ownership? So I think by looking at these things in the round and looking for win-win opportunities, and I think there are often lots of win-win opportunities here to reduce environmental impact, reduce cost, and also think about making more simpler systems that have less risks and that have a less security attack surface, for example. But is it just about designing and coding better software? Should we just go and design and code better software? The question I would ask is what software? I think many of us in well-intentioned ways who are working on enterprise software, so I should say Scott Logic, where I work as a tech and data consultancy, and we do a lot of work with large enterprises, large financial services and public sector clients. And the challenge here is that people want to make an impact in their day-to-day development roles, but the danger is that they think about the wrong software. Enterprise software, particularly stuff that's just internal, only has a handful of users, maybe a few hundred or maybe a few thousand users, is probably actually going to have a relatively small impact. So if you're going to put your developer focus on somewhere, should it be your enterprise software? It depends, right? But the world of open source software is massive. So thinking about like optimizing your own code versus going and looking at the open source world is something that you really need to start, we all need to start thinking about. Now, there are some exceptions to this, right? If you're a large, massive consumer brand and you have millions of customers, if not billions of customers, then yeah, sure, you're going to have more of a direct impact if you optimize your website, for example, and reduce its impact when a consumer hits it. Or if you're using technology to optimize an industrial process. So say you're a big manufacturer or a big industrial organization and you're using tech to reduce the footprint of your own operations, then of course then there is more of an impact. And there's possibly more of a justification for spinning up the technology in the first place if it can wash its face with perhaps the environmental savings that optimizing it brings. But open source, so this is my kind of my main point for the open source community here really is, given how big the open source software community is and the amount of libraries there are out there and how much they're consumed, if we optimize the open source code bases for sustainability and efficiency, that would actually drive a far bigger impact for our coding efforts than just optimizing our own little projects. So if you have a popular open source project with lots of deployments, I'd really like people to start, the maintainers to start thinking about having sensible defaults around sustainability. A bit like we've done for security. There's been a big drive, isn't there, around making sure that you don't ship software or publish open source software with obvious security vulnerabilities or configurations that will trip people up. So we need to start doing the same for sustainability so that these things can follow sensible efficiency principles, some of the things that the Green Software Foundation talks about, which I'll touch on in a minute. We need to start kind of baking these things in, much like we bake in other considerations like security. And so, yeah, one of my main first points here, there's a couple of takeaways. The first one here is, think about using your community efforts and your coding efforts to optimize your upstream dependencies rather than necessarily thinking about your own little project, because it may not be the right thing to optimize. But going beyond code, I think one of the other things I see in the work that we've been doing and in my career is we over-index on software engineering. And actually, there are other parts of the tech landscape that we should be considering. One of the things that I'm really pleased to be announcing today as part of attending this conference is a new proposed standard that we have pulled together, which essentially breaks down the technology landscape for most organizations into 3 main buckets. And this is important because the development, the software coding effort, is only, as I say, one small part. And as a developer, you can look at this landscape and look at where your code or where your project has impacts. So techcarbonstandard.org is where this lives. So there's a nice website that we'll build out. It's open source. It's on GitHub, and we'll welcome people to collaborate and get involved. But let me just kind of walk you through this at a high level. There's upstream emissions. That's relating to the embodied carbon I was just touching on earlier, the materials, the manufacturing, the production of hardware, but also software. It's purchasing employee laptops. It's the networking hardware. It's all the data center and server hardware if you're running your own data centers. We're calling that category U, and we're aligning that with, for those of you who know the greenhouse gas protocol scopes, that's largely in scope 3, mostly in scope 3. Then we move on to operational emissions. So this is what I was talking about, the electricity consumption, the running of your tech. This we're calling category O for on-prem. So those are things where you run and own your own infrastructure. So that's servers and storage, networking devices, your employee hardware. And then if you have your own generators, backup power generators for those on-premise data centers, that's category G, and that's scope 1. Category O is generally scope 2. And then there's indirect. For those organizations that have gone down the public cloud route or managed services route or are using a lot of software as a service, that's what we're saying is category C, C for cloud, and is scope 3. And then the downstream emissions one, and this is most relevant for those organizations that have a big consumer kind of presence. It's the result of your development. It means that the software we build runs on people's devices and has an impact through the device. So if we write really inefficient code or badly written code, that's potentially using up more energy and more hardware on the end user laptop or phone. And the other thing this contributes towards is the fast fashion for devices, right? If we constantly throw hardware at the problem, it forces people to upgrade their devices more often, rather than writing efficient code, which means people can keep their devices for longer because they're not being forced to upgrade. And this downstream impacts and downstream emissions comes from the end user device running at the end of the chain, running the software, and also the network data transfer that's related to that. What we've put out of scope is things like people, buildings, and travel, because those are already covered by other greenhouse gas protocol standards and other ways of measuring the sustainable footprint of your organization. But we think this helps for a number of reasons, because if you don't have this sort of structure, what the world we're in today is we have very high-level guidance from the likes of kind of McKinsey and Deloitte of this world, who talk very high level at the C-level about how you should improve the efficiency of your technology. And then we have lots of great grassroots efforts going on around sort of cloud and other things, but there's nothing that really helps someone navigate this space and work out where their big impacts are, because this varies for different organizations. Some organizations it's massive in the operational space, others it's all about buying employee hardware. We need something to help people navigate and understand where their problem is, so that they can then start to optimize the right thing. So then my second point is the value of the open approach to sustainability. The value of open data, these projects that are out there, these great community efforts to really move the needle on the impact that tech has. And the reason I think this is really important is this is a global challenge, right? It's not one organization or one tech company or one end user organization that's really a problem. It's a problem for all of us, and we all need to get on top of it. So let's use the power of the commons, the power of open source. And I appreciate I'm probably preaching to the choir a little bit on some of this stuff. Transparency is really, really important in this space, right? Otherwise, you get greenwash. You get people making claims that are unsubstantiated, that aren't really true. And unfortunately, we have a fair bit of that going on in the tech space at the moment. We have people making claims that public cloud, for example, is just greener and everyone should move there. Not always true. It can be more efficient, can be cleaner, but it's nuanced. It's not like a done deal that it is. And the transparency, unfortunately, is lacking from some of the cloud providers to really be able to tell if actually moving to the cloud would be better for the planet in the round or not. So this transparency is really, really important. Shared reference data points are really, really important as well. I think for some examples, how much power does the Mac here consume or the Dell laptop? At the moment, it takes quite a lot of scrabbling around in data sheets, product data sheets, plugging in power meters and things like that to get real data points to kind of actually estimate accurately. And we've been talking a lot at this conference about AI, and actually Hannah Smith from the Green Web Foundation and I were just sort of joking. No one seems to be talking about the environmental impact of AI. Yes, there's human impacts and policy impacts and so on, and those are really important. But there's an awful lot of energy being consumed. There's an awful lot of hardware. There's a reason that NVIDIA stock is now in the trillions market cap. It's because there's a huge amount of hardware being thrown at this problem. So just having transparency about how much power and carbon is associated with different parts of the technology ecosystem would be really, really helpful. I talked about some of these organizations and projects, and actually there's a blog that we wrote about the ecosystem that's out there. There's some great organizations out there, like the Green Web Foundation. There's the CNCF, have a cloud native kind of component, a tag, looking at sustainability of cloud native. You have the Green Software Foundation, who I'll talk about a little bit more in a second. And then the groups like Climate Action Tech, which are kind of about building an ecosystem and a community around this cause. And then you have other groups like the UK government has the Government Digital Sustainability Alliance, led by DEFRA. And then you also have BCS, and I'm involved with BCS, and they have a specialist green IT group. So there are organizations out there, and going back to the standard I just talked about, one of the things we want to do is help people find and discover projects that help them in those different areas. So when they identify that cloud, for example, is a significant challenge for them, is where the majority of their energy and carbon is coming from, they can go and discover the Cloud Carbon Footprint tool, for example, which is a great open source tool for multi-cloud assessment of your carbon across cloud. So just quickly, some practical things around what we can do, which the Green Software Foundation talk about. So they talk about these three kind of key principles: energy efficiency, hardware efficiency, and carbon awareness. And I think not only do they have impacts that reduce costs and reduce carbon, but they also have security benefits as well. So if you think about using the least energy possible, let's strive for more efficient solutions. Let's strive for less dynamic content management systems where we don't need them. Let's go for simpler platforms that are static, because those are simpler, and those are often more secure because they've got less attack surface in the first place. Hardware efficiency. Let's use the least amount of hardware. I mean, one of the stats we're seeing is that about 30% of public cloud is waste. It's zombie cloud, essentially. It's something that someone spun up and forgot to turn off. Let's minimize that hardware, because that also then reduces your hardware attack surface as well. And carbon awareness, it's an interesting one, and Hannah here today has also recently talked about grid aware, and the difference between carbon aware and grid aware is an interesting thing for those of you who want to get deep into this space. But regardless of whether you go for carbon aware or grid aware, promoting the adaptability and resilience and sort of flexibility of how you run your workloads is a good thing for other reasons rather than just environmental benefit. So Cloud Carbon Footprint tool, what does it look like? It's a dashboard. It's certainly something that we're finding a lot of value in working with clients who are looking at their multi-cloud footprint. Definitely go and check that one out if you're a big cloud user. And so what are we doing by launching all this? We essentially want to help people navigate the space. It's too complicated at the moment. It's not just easy to go and find out what you should be doing. And so, going back to the carbon standard, I'd really encourage those of you who are interested and passionate in this space to get in touch. We want to collaborate and make this better and make it practical. We've got more to come. One of the things, the other component of this is like a methodology. So mapping out where your significant emissions are, measuring them. And I think this is an interesting one. You can go too far with measurement. You can go really deep in a rabbit hole of, I'm going to measure absolutely everything that's consuming electricity. But how much value is that? And you need to be pragmatic about, do you have enough measurement to know you're making the right steps and going in the right direction? And then mitigations. And again, what we want to do is create kind of guidance and advice across all of the areas of the estate so that there is kind of common patterns and common practices that people can kind of build on and learn on. And let's collaborate on that as an open source community and reference and signpost to the great work that already exists from those organizations I already talked about. So, with that, thank you for listening. The Tech Carbon Standard is available at that web address. It'd be great to get some of you involved, or at least raise awareness of this topic, because unfortunately it still shocks me quite how many people don't really understand what goes into running their compute, running their technology services. And so I'm around for the rest of the day, happy to have a chat offline, but I don't know, have we got time for a couple of questions?